I have enormous respect for Dr. Vyacheslav Artyuschenko. We all know him as Slava. Since 1998, he's headed a company in Berlin that has grown into one of the leading manufacturers of specialty optical fibers and fiber systems. They have achieved success through their patented Polycrystalline Infrared fiber spectroscopy probes. This allows for a large range of wavelengths all the way to mid-infrared, enabling process control of the molecular composition of any liquid, gas or solid, even under harsh environmental conditions. But my respect for Slava is personal. I have never met a person with a stronger drive to help doctors everywhere diagnose and cure cancer. He has traveled to hospitals all around the world. He has attended every epic medical meeting. I think he's achieved his goal of making the ideal fiber solution for next generation endoscopy. Now it is time for us to meet the president of Art Photonics at his home base. On Tuesday, April 20th, we'll be heading to Berlin for a live tour through their facilities. And stay tuned to Slava's answer to the epic question. I am convinced you will discover new business opportunities at the headquarters of Art Photonics, the leading chalcogenide fiber manufacturer. Myself, I can't wait to visit Slava, the legend, the man who has worked hard to make an impact on so many lives. Ladies and gentlemen, we are going live. We are connecting live from where I am right now in Nordwijk, accompanied by many epic members who are visiting together with me Art Photonics. We are connecting with Berlin, with Art Photonics, Slava Artyuschenko, president of Art Photonics. Good afternoon. It looks sunny, it looks beautiful, it is great to be here.
I'm very happy, to invite everybody to look what we are doing here in Berlin. Thanks for the nice weather. You can see that we are in this building right now. Our story was really longer than 20 years. And the reason why we are in Berlin is very simple. I fall in love with Berlin in '86, since my first visit to West Berlin, Laser Medicine Center. Then it was a lot of interesting joint projects. Later on, it was historical week in November when Berlin Wall was down. That week was with a medical show, big show in International Center. And a couple of days after the show, we heard this great announcement, and I go with my friends to destroy Berlin. So, and then there are more reasons here in general, in Atlas, which is the biggest technology.
I'm going to ask your cameraman to get a bit closer to you because it's beautiful but a bit windy and we cannot hear your words.
Yeah, noisy. Yeah, it's on the street. But here, unbelievable, but the Berlin Wall was only 100 meters from here. It's in that direction. It's a channel which separates West Berlin and East Berlin. In general, we are in East Berlin now. And here it's the biggest technology park of Germany. It's more than 1,300 companies, institutes, what else. So that's why maybe we go inside from the noisy street. It will be more easy to explain you why we are here.
Thank you so much. It is great. You've been there since 1998. It is a fantastic area of Berlin. I actually do recommend all of you to come and visit what we're going to see now, to come and visit in person. Slava is a very welcoming person, and we always have great meetings when we actually come with the EPIC members. This meeting is going to enable many business opportunities. I have with me a nice group of people who have come to visit with me. You have any question, any participation, please, I would like to encourage. But now we are inside, there is no wind now, and I would like to ask you, Slava, why did you select this beautiful building for the company, for Art Photonics?
I should show you a couple of pictures. When it was East Berlin, and we started here in '98, this part of Berlin looks like that. So, and then we are in the area which is named Octagon, and you can see how it looks now. And we were the first tenant in this building. So in 7 years ago, there were no buildings like that, only the central part. And we were the first tenant in this building. Now there are much more. So here you see kind of, let's say, very special symbol when Octagon in Adlershof was launched. So, and this building was simply good because before I started a company in 98 and I was alone. No venture capital, no funding, just something, you know, to do with organic growth. And with this kind of organic growth, 7 years ago, we were already almost 20 people. Not enough space we rented in the previous building, not far from here. That's why we designed space over here. You can see several companies. And we occupy empty shops, first floor and second floor. So that's why I will introduce now my team. We should go to the next floor from here. Okay, few minutes, few seconds.
Let's go upstairs. With me in the room, we have companies like Art Photonics doing testing for the fibers. We have companies like Coherent. We have companies in the room like the CSEN, the Center for Switzerland, Optical, also from Switzerland. We have Airflex. Everybody's here looking to do business with Art Photonics. We are all the way up. And for me, whenever I visit a company during this time, the first question that always comes to my mind is how do you run business with your team during these very bizarre times, during COVID-19 times? How are you running business with team? Okay.
We follow the rules. First of all, you see Uta, our secretary.
Hello, Uta.
When our guests come in here offline, then we use all this kind of, let's say, standard stuff for temperature measurements, you know, for liquids, masks, what else. And of course, after reception, after this nice design, and I will introduce our design manager in a minute. So we are going to the conference room where we have our life now with, how to say, all restrictions related to Corona. So okay, that way. Design of this building space, Elena Bullman, our design manager.
Hello, Elena.
Our sales manager, Peter Tanzer.
I know Peter already, great to see you.
Yeah, we cover big area, you know, he covers, you know, whole Europe, Africa, Antarctica as well, a bit, you know, for penguins.
Penguins as well.
Okay, Benjamin, our supply chain manager. He is really doing a lot. He is an interface between our sales team and our production. A lot of work to do, especially in this kind of difficult Corona time. So I will show, first of all, screen can wait a bit, you know. So Alexei Bocharnikov is our product development manager.
Hello.
And product manager.
Hello, Alexei.
Yeah. Tatiana Sakharova, she is fantastic technologist. She is, let's say, great motor, you know, to develop our new technologies for mid-infrared fiber optics and different products. And you see, we are now more than people on the table. We see Misha Yosifov on the screen at the left, our sales director, and Mikhail Mirakyan. So Misha in the moment is close to Boston in America, and Mikhail, he is in Yerevan. So he covers the whole area of Asia, which not only Asia, Australia as well. So very big piece of planet. And Misha is with us a bit less than 1 year. He is fast progressing and we're really growing. And I think it will be maybe not a question to me, Jose, will be better to ask Mikhail and Misha how we really manage sales in the time when there are no exhibitions, no conferences offline, no guests in the companies. So maybe Misha, you can answer. Or so
yes. Jose, first of all, thank you very much for the opportunity and great.
for promoting the European photonics and moving it forward, and all the alliances and collaboration is just fantastic. And you have our gratitude for that. So the question is how we are proceeding in these difficult times. I mean, it's not easy. We're human. We are social animals, like we call it. And it was a little tough, to be honest, to adjust in that swift change, especially with all the restrictions, travel restrictions, and how we are going to align our strategy accordingly. But I believe with our team, we moved really swiftly because we're a small company. We can adjust faster. And that's why all of our sales and marketing is now online, like most of the companies. But what differentiates us is probably that we are more focused now. We're trying to provide solutions for directly to the customers, and we are targeting end users instead of trying to go everywhere, because now we have a focus. And another good thing about us is we spend more time and effort on marketing now, because we're also trying to teach our customers, potential customers, what they can do with the fiber probes as well. Because not everybody is educated for those. It's not like you have a car and you need spare tires. No, it's not like that. Like Michael likes to say, it's more like a what do you call it, Michael? Yes.
This is fantastic, by the way. We are connecting to Berlin and having a conversation with Boston. And this is actually for me, this is the magic of the COVID-19. Where in the beginning it was a challenge for us to be together because of all the restrictions, but humanity always resists. And now I can see that we are closer than ever. We are closer than ever, and that has been for me the success of the 2021. Nothing can stop humanity. Nothing can stop photonics. Thank you so much for being with us. You say thank you to me. I say thank you to you. I want to ask a question to Slava before we go into detail, because it's a very important question to me. Very important. We enter the reception and we see a beautiful painting. Then I look at this and I see, what did you name the company? Art Photonics.
Okay, story is a bit funny, because from very beginning, my friends, they said, Slava, name of the company should be started from A, just to be on the top of the, let's say, lists. And then it was named Advanced Research and Technology in Photonics. So A.R.T.Photonics. And after a few years, friends and customers, they said, why these dots? Name it Art Photonics. It's easy. And it's understandable because, you know, in general, we are really, how to say, not a usual company who makes a lot of standard product for the shelf, for stock. We are really doing, I don't know, more than 60 or 70% of our product are always customized. And you will see, let's say, a bit later when we go through the company, that we do for each application something special. We do have standard products, and some of them are produced in big quantities. But we are always keen to be not, how to say, a prêt-à-porter company. We would like to be a boutique. So that's why we are really kind of, let's say, art photonics, art in photonics. So,
Art in photonics. So how much can you love that? For me, what I love about art photonics is that you cover every wavelength from 300 nanometers all the way to 16 micrometers. So really, it's like a broad wave. But you talk about, since we joined the companies, we started the company, you talk about production. And so for me, the key question here is ISO certification. For how long have you had it, and what were the hurdles to getting a specialty fiber manufacturing, developing something very, very new, ISO certified?
I think question is better to ask Alexei, because he was behind all the procedures, and certificates are on the wall. I don't know, Ivan, if you can simply concentrate here. How long we are in this?
So we are for many years certified by ISO 9001. So we've got our first certificate in 2010, in June.
2010?
Okay. Yeah, so we are already 12 years certified, and we, of course, every year it's confirmed certification. So that's why we always try to, how to say, follow very simple 3 principles. Okay, highest quality, reasonable price, and fast delivery to satisfy customers, you know, with their sometimes dreams. We knew that sometimes customer comes to us after, how to say, no chance to find somebody who will realize the dream, and they are coming to us. And then we are doing this kind of magic products over here. So,
you know, we're going to talk about certification later, but also about the medical part, because for me this is one of the jewels. You are one of the jewels of the medical developments for photonics in Europe, and I want to address that later on. But before we do that, we talk already about the COVID-19. We talk about the name Art Photonics. We talk about the certification. I know you have planned for me a very busy 45-minute visit. Where are you taking me now? What is the next thing?
yeah, I think Alexei should show how we are trying to start realization of the dreams of the customer. Alexei, okay. Let's go to your room. Yeah.
We are going to walk now to Alexei's room.
Yeah.
Alexei, while we work there, I can see the art. I can see the art of Art Photonics, which makes me very excited. You know what is a pity? That we cannot just all of us be there with you. Really, but it doesn't matter because we are virtually connected all over the world, and we are also live in YouTube. So I'm going to say hello to the YouTubers, and we reach Alexei's room. Alexei, hello. What do you have there? What are you going to show us?
So I would like to show to you how we proceed with customer requests. So we start to clarify with the customer's needs and problems and prepare a special solution for it. And we use retracing software to develop and optimize the optical system. Then we transfer the optical scheme to the 3D CAD software and add mechanical components to hold the optics in a proper place. And soon 3D models and drawings of real parts for prototype manufacturing.
We are having some slightly connectivity problems, so I'm going to ask our cameraman to get a bit closer. We are having a bit of connectivity problems. This is one of the magics of doing things live. That sometimes this happens, and we always know how to solve it. But before we solve it, I would like to go to some of the people that we have in the room. I would like to go to my friend David Robinson from Art Photonics. David, you came with us today to the company visit of Art Photonics, and I really like that you are here with us. When you are visiting a company like Art Photonics, do you spot some business opportunity? What can a company that specializes in fiber testing do with Art Photonics?
Yeah, it's great to be here today. It's one of the great privileges of my job that I get to tour factories. I love to see how companies operate and see how they organize themselves. And I've been missing that over the last year, so it's great to be able to do it virtually. But Art Photonics is a company that we've been looking at for many years. Felt that there was some possibility for collaboration there. Obviously, I met Slava at some of the meetings that we've had, in Denmark and other places. But yeah, I think the kind of work they're doing is really interesting, and I just wanted to find out more about the business and see what sort of challenges they had for measurement, if any.
Fantastic, David, and it's also great to see you. I really can't wait to see you in person again. But we have the connection back with Alexei from Art Photonics, who's showing us really how to go from fiber to fiber products.
Yeah, so at what point it was broken, the connection? I can start from the beginning, no problem.
Start from the beginning, that's always safer.
So we developed the system, the optical system in the ray tracing software. They optimize it there, and then transfer this optical scheme to the 3D CAD software. So, and in this software, we add mechanical components and to hook the optics in the proper places to the fibers. And as soon 3D models and drawings are ready, we can purchase the real parts and manufacture the prototype. The prototype will be tested in the laser or spectroscopy lab. It depends of the product type, and soon the results are satisfying us or customer. We give the product to production.
How does it work? So when some of your customers, you're actually making lots of different probes for testing. Some of your customers want a product. Do you co-design the product with your customer, or do you prefer to do design yourself based on his wishes and dreams?
Oh, so it depends on application. So in some cases, we know better what is better for the application, which type of the product as customer to use. And in other cases, we are hearing the problem and the needs of a customer to find a solution for him and to make a special product based on the specification. Now we are going to the spectroscopy lab and laser lab. So
yes, now it's when it gets interesting. We've been all waiting for this. We're going to the spectroscopy lab. You can see now that Slava is wearing a proper attire for going to a laboratory. I do miss that very, very much. Slava, where are you taking us? We go to the spectroscopy lab.
No, a bit vice versa. We shall start from laser room. Right now, guys are ready to show something. So we have a safety rules, of course, and then, you know, you should knock. Okay.
Always knock.
And
they all wear the proper attire.
Okay.
Laser
protective rules.
So safety first.
Thank you so much. I should have brought the mine.
So our laser lab is dedicated for quality tests and investigation performance of different infrared fibers. So using our CO2 laser, we also have CO laser, different medical CO2 lasers, YARC laser, and into our European project called Miracle, we also got quantum cascade laser with 8.8 micrometers wavelengths to develop our first infrared fiber-coupled quantum cascade laser system. So yeah, we have different parameters, proselyters for infrared, visible, and near-infrared regions. We also have this infrared camera for special tests for polycrystalline fibers and solid waveguides.
Here is where you can test any spectroscopy need from the 300 nanometers all the way to the 16 microns, and you have all the sources and detector cameras to make that happen, and that's very, very exciting. Tell us what experiment are you running now?
So now I'm testing our polycrystalline fibers and our new amazing hollow waveguides here. So we test the transmission of CO2 laser power and investigate their parameters under bending, their beam profile and transmission drop under bending. So, for example, here you can see the beam profile or intensity, output intensity distribution from the hollow waveguide coupled with quantum cascade laser. And if we touch it, we can see how the speckle is playing.
Yes, I'm going to ask the cameraman to get closer to your hand because I'm not sure what you are doing. What are you manipulating right now? So if you can tell, okay.
Yeah, and also we can demonstrate the flexible delivery of CO2 laser using our polycrystalline fiber. So let's look on this.
The polycrystalline fiber of Art Photonics, the reason that we are here.
Yes.
And he is doing
Here
the laser ablation in a fashion. Okay, no, please write epic. Don't write a funny face. What an amazing demonstrator. Laser ablation with a fiber, with a polycrystalline fiber. That's a good way of starting. That's a great way of starting. I would like to ask you, which waveguides are suitable for CO2 and other long wavelength lasers?
We did tests with our whole waveguides to make a comparison with polycrystalline infrared fibers. So whole waveguides, our whole waveguides have larger bandwidth losses, but they have much smaller output numerical aperture, so which makes them much better for high-power laser applications. And as a transmission, they have similar transmission to polycrystalline fibers with a special.
When you talk about high power laser applications, we are here talking. I mean, this for CO2 and this kind of lasers. What kind of power limitations do you have? What is the highest power that you can actually couple through one of the polycrystalline fibers?
So now our laser is about 40 watts, and we test 10, 15, 20 watts laser.
You can't imagine how amazing it was to see you doing the laser ablation directly in front of us and basically writing with a polycrystalline fiber. That was really beautiful. Slava, I loved it. I really have to come to Berlin and I want to do it myself. I really want to film a video in which you write epic with that fiber. That's going to be fantastic.
Jose, I would like to add a bit, some comments to the good introduction from Alex. For the high power delivery, we are not trying to, to beat somebody's record, because we are focused on medical applications with human. We are not making barbecue from elephants. That's why, it must be smart systems. That's why question how with the minimum power to reach the less invasive effect for laser surgery, how to select proper wavelengths, and we developed together with Technical University of Berlin, we have a project to develop smart systems. When you move the cable, at the same time you can really measure temperature in non-contact mode. It's good for transplantation of organs, it's good for the welding of vessels, and so on. So that's why I'm trying to promote so-called smart laser systems, which really more sophisticated than very first lasers when more power is better. It's not true. It's good for barbecue.
You know what? I always like to connect the members, and we are now in a spectroscopy lab, and we already saw a demonstrator, but the first thing that they told us is that they have all the laser source and all the cameras to do spectroscopy systems. Peter Totrup is the CEO of Enlir, one of our members in infrared cameras, in the mid-infrared cameras. Peter, when you see a laboratory like the one that we just seen, what is the first thing that comes to your mind? What kind of room for cooperation can we have here?
But we already have a good cooperation with Art Photonics. We're actually using one of their probes for ETR. So I can actually show a very, very short video from that, so you can see what we do together with these guys.
It is so nice to when you had the customers showing your products. This is what I love about Epic. Tell us.
So here you can see a video of our using our ETR probe from Art and our spectrometer together. And here we put some alcohol into water. This is live, 10 frames per second.
We are not seeing the video moving, but we are seeing that you're actually detecting a peak at 3.25, 3.2 micrometers corresponds to the alcohol.
So I'll just drop it out and stop sharing. But I mean, we use Art Photonics probes, so we are having a good cooperation already.
Thank you, Peter. I see great projects we shall realize soon together. It's wastewater monitoring and moisture detection and a lot of other applications.
Yes, exactly.
But I'm watching the time, Jose, and I think we should really show spectroscopy stuff and then our production.
You are the master and commander, and I follow you.
No, Commander is new, but I remember, let's say, that we are limited in time, unfortunately. Okay, we go to the spectroscopy lab. Thank you, Sasha. Thank you.
And when we walk to the spectroscopy lab, well, it was closed, so we're already here. We are in the spectroscopy lab and we are meeting two gentlemen. Good afternoon. This is Jose from
I would like
EPIC.
to introduce. So Iskander Usionov is our R&D manager for projects. And Valentin Mironovich, he simply helped us, to do a lot of different things, from production of infrared fibers and probes up to the measurements. And in this room,
hello, Alexander. Hello, Valentin.
So just maybe one by one, but in general, maybe Iskander, you will describe what we have here.
Yes, of course.
I think most impressive is multi-spectral fiber system.
Yes, here is so-called, so we call it like a multi-spectral fiber system where we combine all 4K spectroscopic methods. Yes, it's Fourier transform infrared spectroscopy, fluorescence, Raman spectroscopy, and near infrared spectroscopy. We connect all spectrometers and also our specially designed combi probes, yes, together in one process, and then we can monitor different reactions. So how the components inside change, how the mixture mixed inside, yes, and so our probes, yes, and spectroscopy systems designed mostly for reaction monitoring and control. And during the reaction, yes, you can control how different components are mixed inside, yes, and then you can see and control your process, industrial process, yes, or your special chemical reaction without sampling. So you don't need to make a sampling, bring it somewhere in the lab, yes, and here on the screen you can see how really the spectra change during the reaction. So we can see.
Let's see the spectra changing live.
Yes, spectra changing live. So for example, here is a dissolution of sugar, and you can see how this transmission, yes, so it's absorption bands of sugar, how there are more and more and more sugar.
I have Florian from IR Sweep with me. I want him to see this as well, and I will tell you why. But for me, the first question that comes to your mind is that you think this is water. I'm not going to tell you what it is. Can I just send you some samples? Can I send you some samples and I can actually have real testing of these samples? So what maybe you think is water, it's not.
Of course, we are using all our unique set of spectrometers and samples to test customer samples. Yes, and also we are also very welcome all you, our customers, yes, to come here in Berlin with your samples and to try all the spectrometers. Yes, and moreover, these tests, they help customers see and if our solution, our probes, yes, unique probes, together with different spectrometers, spectroscopic systems from 200 nanometers up to 60 microns, if they can really measure their samples, yes, and if our probes can help them.
Florian from IR Sweep, when you see this laboratory, for me, process monitoring is the market. Process monitoring is the market for this technology. You are a success story of Europe in process monitoring, integrating mid-infrared technologies. I know you collaborate already with Art Photonics, but what kind of things come to your mind for a possible collaboration, further collaboration?
First of all, of course,
for speed measurements, sorry. I think it's excellent actually that you have what you have here in the lab. It's actually the first time I see that live, even if it's virtually. It's very interesting. My question is actually, what is the longest fiber optics or peer fiber optics currently involved for reaction monitoring with FDIR?
In the past, we really did one, for Pfizer again, our joint customer, and it was 5 meter long. But in general, let's say our progress with you, then it's already 10 meters. I think we can go even up to 15 meters. Of course, will give us more chances to make not only a single fiber, it can be, spider system. It can be, let's say, multiplexed fiber optic system, which will connect one spectrometer, dual com spectrometer from you, for example, with several points of reactor. But here, Florian, I think that we should also think about not only process monitoring, but about, let's say, Exhalation monitoring, because COVID has a specific biomarkers in exhalation of the patient. So we can also use your super high resolution system, to detect a patient when it goes through the gate in airport.
If you say high resolution, you mean spectral or time resolution?
Spectral, because time as well, because the best when the passenger will even not feel that he must stop and wait for the measurements. He must go through the gate, and then his exhalation within few seconds will be already analyzed to detect specific biomarkers.
Slava, I see a lot of equipment in that spectral lab, not just a demo, but a lot of equipment around. Can you tell me a little bit of what you have and for which purposes?
Yeah, just to mention that multi-spectral fiber system we developed was developed for our biggest investment. It was worked together with Charité, with the biggest medical center of Berlin, to detect tumor margin. We have even right now projects running with our partners in Rotterdam, and Riverdi is also a member of EPIC, so with Erasmus Medical Center. And for that kind of measurements, we need biopsies. So for example, when we started with kidney, you can see here, it's not a spectrometer, it's a freezer, but this freezer works for minus 80 degrees to keep biopsies alive. And when we should make our probes sterilized, we used autoclave, which goes with a temperature of 240 degrees, just to see how the changes, if it will be changes in spectroscopy probes after this kind of sterilization process. But what is important that we would like to mention, Valentin can show a very good solution for today end users of many FTIR spectrometers. 90% of spectrometers in the world, they have only sample chamber. So, and in this sample chamber, you can use fibers only when you have a coupler. So Valentin, you maybe will say some words.
Okay. Thank you, Vyacheslav. So here's a fiber probe coupler. It's a special device with a set of the mirrors that focus the light from the light source of the spectrometer in the fiber, optical fiber or fiber probe, and out of this for the focusing into the detector of the spectrometer. I align all of these couplers, check all details and all mirrors, assemble it, align it, make a quality control for the highest, to reach the highest signal level of the optical coupler. And of course, before the shipment, before the delivery, we make the final quality control. And now I'm working with our new version of the universal coupler, and this universal coupler fits to the most of the FTIR spectrometers. So here you can see the quality control process with the program in the special software, and here you can see the fiber probe coupler, our universal coupler.
So here there is the first question that comes to my mind, Slava and Valentin, is that when I go to the customers who make spectrometers, and many are members of EPIC, I see their products and they don't have fiber probes. So why don't they have fiber probes, and how do you help these companies?
It's a very good question, because I also don't understand why people who are limited, by their bench spectrometers, they simply don't think about fiber optics. Which simply will give another life, another horizon of spectroscopy applications, process spectroscopy, medical diagnostics, everything, but then we should simply we should really put much more efforts in advertisement just to let people know. And this is, we are doing this year, especially in Corona. It's a digital world, and if you are not on the surface of the digital ocean, you are not visible. So that's why we try to improve this, and EPIC is great for us, not only because of advertisements through EPIC, but we have really great partners which simply help us with infrared imaging, with spectroscopy, and then through the team, it's easier to make advertisement. But now I really would like to say that we have not much time left.
Oh, don't look at the clock. People are available. Don't worry. Just keep it as exciting as it's been. It's been really exciting, right, Lars? For me, one company in Epic, NanoPlus, is moving up the value chain, right? So they make a laser for every wavelength, but now they move up the value chain. When you see what they are developing here, which are fiber probes for sensing, Lars, what kind of room for cooperation? What kind of things pop in your mind from NanoPlus?
There is, of course, already a cooperation between between our two companies, as you may think. Yeah, I think it's quite interesting because some of our customers they say, oh, you have these nice opportunities of all these wavelengths, but how do I get my photons there where I want them? Right. So, and if we could do that with a fiber, that would be very much appreciated. So
there is no better way of guiding the light than with a fiber, of course. But yes, I just saw a snapshot of something super cool, Slava. That machine looks very, 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 very different. What's that?
Yeah. Okay, this quantum cascade laser, I believe synergy of quantum cascade lasers and our mid-infrared fiber optics will really make kind of revolution in the future. But now I really would like to attract your attention to the machine, which simply does a lot of actions, simply pull the fiber, and Valentin will say a few words.
Okay,
this looks like a robotic
so this
system.
is our special machine. So, and it was specially developed and manufactured for the cutting of the silica fiber. The machine take the fiber from the spool, cut a short, precise piece of fiber, strip it off from the protective polymer jacket. So, and it gives us the possibility to use these short, precise fibers for our big line products. Yeah. So, and we can spend some time, avoid the handwork, and receive the precise product like this. And this machine you cannot buy anywhere with these special properties.
And then, machine really produce a lot of fibers because we must deliver more than 1,000 per week. And you can see that this machine itself can really do a lot of, cut pieces, within day and night. So that's why now we go to the quality control and production to show what we are doing, the rest, real production.
Slava, when we walk there, I'm very impressed with that machine. I think the investment on automation is something that I have seen that you are taking very seriously. What's next? How are you gonna invest further on this? And we have another person here with us. Hello, good afternoon.
Daniel, is our great guy, multifunctional, a lot of skill in different actions. But here he shows us, quality of fiber optic stuff. You saw the machine, but machine goes later with gluing of ferrules, and we should.
Small fiber pieces will be glued in a ferrule after they are controlled for length of fiber.
I'm going to ask the cameraman to get as close as you really can for that fiber, as close as possible without touching it, because I really want to see it. Okay.
So that are our fiber details. We're producing around 1,000 per week, and every single piece is checked for different parameters. Most important, the quality of the polished surface inside the ferrule. Yes.
So we are doing here is monitoring the core of the fiber to see if the clip is with the right properties. This is you do fiber by fiber, one by one, with a lot of patience. Is there? I always ask this: is there a room for further automation of the process? Because of course we want to take this to further volumes.
We think about it.
We'll think about it. Yeah. It's not an easy task, and it will be step by step. But yeah.
It's in plans, because
right now it's work for hands and for eyes.
Okay, anyway, we'll go to the production because we have only 15 minutes left, but it's a real big piece of technologies to show you. Okay, it's a lot of quality procedures, and Daniel did not mention very important figure. When we deliver even more than 1,000 per week,
yes,
100% of fibers accepted by the customer. So we have no rejection because of our high level of quality control.
You
So
check
this is
you all these thousands fibers per week. You check them, each of them
absolutely,
individually.
yeah. Each size, all parameters. It's not only polishing; it's also gluing quality.
For a back of the envelope calculation, how long does it take you to check the core of a fiber?
Overall measurement of one of these pigtails is about 5 minutes if you add all procedures, maybe 6 minutes. But it's around 1,000 per week.
Oh my God.
Yeah, exactly.
Exactly. Okay, we go downstairs.
I'm very excited about this. We have many companies who want to interact with you about this. They have many people really writing this down. I hope to really solve. Well, I hope to really help furtherly the improving the testing of these fibers, because at the end of the day, this is obviously a bottleneck in the production. So for the companies in the room, this is a huge opportunity. And now we are walking downstairs. I feel underdressed. I really would like to have a jacket like that one. Where are you taking us now? I really want to see more production of bundles. This is actually my passion. So where are we now?
It's assembly room for all Silica products. And as the chef of this production is Alexei, I will give him the stand, you know.
Hello, Alexei. It is good to see you again. And now we are in the production facility for the fiber bundles in Silica. What is over there?
So we have 9 stations for assembly, so 9 tables for assembly, and we have additional long tables to assemble long products like fiber bundles or fiber cables. One of example of our products is small fiber pigtails. We produce them in the quantity of 5,000 pieces per month, so it's relatively big quantity. And for this product, we got fibers cut by the cutting machine upstairs, and we glue this fiber into the ferrules, and then we polish them in the polishing room. So if we will go through the
I see the present and I always think about the future. Are you planning any new things, any developments in the assembly technologies?
Say again, please.
Are you planning some new developments in the assembly technologies? I look at the present and I think about the future. That's always me.
Yes.
Right now we are in progress, you know, with new automated procedure for gluing of these fiber optic pigtails. So this is work which we expect, let's say, with results in summer. So that's why here, first of all, we are already limited because of Corona by number of people, and we really need automated machines who will simply produce more per day, per hour. You may notice that with 9 stations, we have only 1, 2, 3, 4 persons in this room. Why?
Yes.
Every second table, because of Corona, we must use 2 shifts. So not all the people are, how to say, allowed in one room. So that's why, in general, you know, we are a bit retarded, but we do it with 2 shifts. So this room is mostly for assembly, and it's not only, let's say, this pigtails. You can see, for example, nice products over here.
Okay, let's see the product. A cameraman, as usual, as close as you possibly can to the product. And we see a polycrystalline fiber, not surprising, but what's at we have on one side the connector, and on the other, it's a silica fiber. Okay.
So it's a special fiber cable. From one side we have a CPC connector, and from other side it's a freestanding fiber with a special tip design. So it's a conical.
And another product, you see these yellow cables.
Yes.
It's a probes used for the petrochemical industry and so on. We supply kilometers of these probes, while each one can be 100 meter long, 200, 300 meter, to control the rectification process, for example, in petrochemical plant. So this is a good sale, you know, to very big petrochemical companies and chemical companies. So And we separate a room for assemblies with a room for polishing.
That's what I was going to ask you. I was very surprised of the separation between the different assembly stations and this room. So I would like to know the reasoning for that.
You can see here stations where we really do polishing. So you can see, for example, Nikolai, our real best master, you know, that he prepare laser cables for assembly. And when they are assembled, you see them over here. They are ready for polishing.
Mm-hmm.
And after polishing can be done by hand. But then there are, for example, procedure which is prepared by Natalia.
Hello, Natalia.
When we prepare discs, you know, she prepares disc, you know, for the, how to say, program of polishing.
We are seeing live the polishing, CNC polishing of the fiber, or the fiber bundles. How long does it take for the polishing process?
So it's at least 5 to 6 stages with different grinding papers, and it takes. We have right now 48 pieces simultaneously on the list. So it takes, let's say, for the final product, it will take 15 minutes.
So after this is truly fantastic. So after having the fiber polish, what you do is to take it directly to inspection of the quality of the polishing, right?
Quality control. Yeah. But we have more complicated procedures because what you have seen right now with this Euromicron machine, it's a polishing of perpendicular ends.
Mm-hmm.
Here, it's much more complicated. You can see something rotating, and you see also the screen.
Okay.
It's a polishing of the fiber end to make it like a needle, conical needle, conical shape. Yeah. And
so with this, you can actually do microstructuring of the fiber tip.
This is a special shape which we, how to say, designed for the operations in clinics.
Mm-hmm.
I already mentioned our project with Riverdi in Rotterdam, in Erasmus Medical Center. What you see here, this kind of fiber optic needles, it's a single fiber with a conical end. And this is the smallest Raman spectroscopy probe in the world. Diameter of the needle is 160 microns. It goes in, how to say, excised tissue for ex vivo test of margins for tumor within, let's say, 1 second for 1 centimeter. And every 100 milliseconds, we see if it's tumor or not. So we are doing this kind of, how to say, 3D mapping of the tissue cut by doctor to know if it's completely removed from the body, or it's still some pieces which must be removed to leave no malignant tissue after operation. To make
did you hear you well? You're saying this is the smallest Raman probe in the world.
Yes. Yeah, because through the same fiber you illuminate the tissue, you collect signal of fluorescence and Raman, and then you split it for 2 spectrometers or 1 spectrometer, and then, you know, software helps to distinguish between tumor and normal tissue. So, and then we do this kind of, let's say, testing of the piece of tissue within few minutes, and doctor can get instructions what he must do next when patient is still on the table. So this is kind of, let's say, new way of less invasive and very, how to say, radical operations to remove oral cancer, which is our target with a project which was awarded by #1 in 2018, Project Rashua. So
For me, I am amazed of the work that you are doing in the medical segment. Gerwin Pappels from Riverdi, I know you are watching. Great, this cooperation is a truly epic cooperation. What is the thing that makes you the proudest? When we talk about the medical market and we talk about the medical probes, what is the thing that makes you so happy when you reach home in the evening?
We are in, how to say, laser medicine. I'm in laser medicine almost for more than 40 years. So that's why, as I mentioned already for the beginning of our interview, I fell in love in Berlin because I met my good friend, Professor Gerhard Müller, director of Laser Medicine Centrum in Steglitz in West Berlin. I met him in Los Angeles during Photonics West in '85. And then we started intensive collaboration, and we are more and more involved. To me, we really produce a lot for industry, for environment protection, but medical field, biophotonics in general, to me is the most interesting for all of us, because all of us, we are not, how to say, biorobots, but nevertheless, our health, our, let's say, lifetime depends how good is our food, how good is our life. And of course, medicine is one of the most important applications where photonics can help. So, but
one thing that I always keep saying, that what really makes me excited about Slava, you have been very successful in setting up an iconic specialty fiber company worldwide, an iconic worldwide fiber company, but is your interaction with the medical market, especially with medical doctors, which has earned the highest of my respects. And on that, I really truly look up to you as a president, CEO, and friend. But let's yes, tell me.
I am ashamed, but I'm really, let's say, willing to show you within last minutes our best products which we have here, which are unique in the world. Let's go to infrared production.
Slava is obviously from Russia, but he lives in Germany. So you can see how excited he is with the timekeeping, which normally I don't really care that much because I'm very Latino. We have a question in the room from Coherence all the way from Matthias. Matthias, what's on your mind?
So I just want to share the excitement, the passion that I saw from Slava for the medical laser. I had a lot of cooperation with him on experiments back then, and I see him very passionate and for the high expertise in medical laser. It's very exciting. And you've been connecting us a bit. Thanks, Slava.
Matthias,
I think with this latest news from Coherent, I assume that the new life is coming for Coherent and for us together, because new projects will be even more exciting. It will be not only delivery of laser power, carbon monoxide or dioxide, it will be also diagnostics and many other applications, infrared imaging and so on.
Thank you.
Okay, where are we now, Slava? What's that?
This is the most, how to say, top secret laboratory, let's say.
Top secret, love that.
Because we produce here mid-infrared fiber optics, and Tatiana will give you a bit more words about it.
Hello, Tatiana, good to see you.
Hello. Yeah. So Art Photonics is now a single company in the world who supplies 3 types of optical fibers for mid-infrared range. These fibers are based on chalcogenate glass, hollow waveguides, and silver halide crystals. We produce over here more than several kilometers of fibers per year. And we possess unique technologies which we continuously develop to keep the highest quality of our products.
Yeah, we can go maybe to show the process. I am proud to be a pioneer of this technology because it was topic of my, let's say, diploma and PhD to develop super high purity crystals to make polycrystalline fibers. And this is really unique fiber because it's kind of nanocrystalline material. So grain size is between tens to hundreds of nanometers. And they are produced in the room where Tatiana maybe can show how we do it.
I think we all notice, we all feel the excitement of Slava, who was mentioning his PhD. I actually did get goosebumps there. Tatiana, where are you taking us now?
There is our production room. We produce over here our polycrystalline fibers. And Valentin, our engineer, can tell and show you the process since he is already in our team.
I am so amazed that you're showing us this. I actually had a bet with somebody in Epic saying, they are not going to take us here. You took us here. This is fantastic. This is a unique experience. Not everyone manages to get in there.
Yeah, that's true.
Yeah. Hi again. So welcome to the reproduction of Art Photonics company. So for this type of production, we don't need a huge equipment, special reactors, and so on. Yeah. So we have now, for example, an explosion process, beform making process, and it sounds simple, but only for the first glance. Yeah. So we make the video fiber using an extrusion process at high temperature and using the press machine. Yeah. So this is the press machine, the furnace, and the fiber pins on the wheel.
I asked the cameraman, without breaking any confidentiality here, to please get as close as possible, without Slava being too upset, because I cannot believe that we are seeing what we are seeing right now.
So yeah, you see the fiber, the fiber pins.
Yeah, tell me about this. How is the manufacturing this manufacturing process different from the standard silica fiber?
So this process can take a whole week because we begin from the preparatory processes, like making the preform, like making the core and cladding. After this, we are going to the extrusion. So it can go like for the week. Yeah, and after the end of the extrusion process, so we
can the cameraman get closer again to the extruders?
Okay.
Sorry, but I really need this. It's really great.
Yeah. So
you said a whole week. So, and then we had the fiber there. It is not a drawing. It is a drawing process. How is it different? This drawing process to the silica fiber drawing process that we are used to.
So, for example, so this process is special because we have the high temperature. Yeah, so near the So and we have the pressure like around the 20 tons. Yeah, so we have the special structure of the furnace. So that's why it looks completely different from the silica fiber production.
It's like a metal wire.
Yeah. And of course, it's the other material. Yeah, after the end of the extrusion process, we wind the fiber carefully.
I measure fiber in distance. So how many centimeters or meters per hour or per day? Can you give us some numbers on the production speed?
So for the week we can produce near the 100 meters of this type of fiber. Yeah, so pure fiber, for example. Yeah, and of course it can be more and more and more. Yeah. So of course we have another process, and you see it. And of course we need the special conditions such as a high temperature. Yeah, so the vacuum. The time period, and all these conditions we control with our devices. We have the special software to collect the all data, to analyze our production process.
Oh my God!
And of course improve it.
I'm too excited. I keep interrupting you, but I'm too excited. So you said you had a preform as well, right? Can you show us the preform? I really want to ask the camera. I don't know without breaking. I'm super careful here. So if you don't want to show it, it's fine. I'm quite amazed.
Yeah.
Okay.
So this is the preform. Yeah. So how we make this? We have the special silver halide crystals. Yeah, and we use it separately for making the core and making the cladding. And after this, we combine it together and make it, and make this cladding core preform. We make it using the vacuum furnace with a high temperature, so with the vacuum, and of course we control all the parameters with our equipment, and it gives us a high quality product.
It is for the people who are watching this. It's very unique that we are seeing. This is really, truly unique, and I'm really happy to see that what they are showing us now, and I think this enables room for many, many, many cooperations. I would like to ask you now, when we see these production facilities, are you seeing a growing need? Are you seeing a growing need on this kind of specialty infrared fibers? Tatiana wants to answer that. Tatiana, tell us.
Yeah, I can answer. Yeah. Of course, we see the growing need in fibers for mid-infrared range. And to secure our production, this summer we start our own crystal growth for silver halide crystals. So in this year, we'll have a complete technology cycle in our company.
And I would like to add that in general, just for the time limit, it's difficult for us to show you what we have else. We have another building, another space in chemical laboratories where we produce already hollow waveguides, and where we are starting to grow crystals to make a deep purification of silver halide crystals and growth. And for the market, to your question, Jose, about the future, fibers like this, which are extremely flexible, have not only interesting future for laser power delivery and for spectroscopy. Huge market is infrared imaging. Just to give you two figures, endoscopy market on the planet is about 40 billions. And believe me, if
did you say 40 billions with
billion? Endoscopy, classics. I mean, Olympus, Storz, Wolf, classic illumination company. Schott is doing excellent endoscopes, even single. But they are based on glass fibers or silica fibers, which are really limited in transmission up to 2 microns. But when we take this fiber, and this is polycrystalline fiber, so with this fiber, we can do something fantastic because it's transparent in the range of infrared cameras.
Yes.
When you see right now infrared cameras, which are used to measure your temperature because of corona with high precision, just imagine that this fiber bundle can be used for the infrared array, and then you can make infrared endoscope, which goes into the human body, and you can see tumor on the wall of esophagus or on the wall of stomach, because tumor is always half a degree warmer. We have excellent project with one company who really control, it's a special procedure against arrhythmia, to use radio frequency ablation catheters to heat up nerves which simply send false signal. With this company, we develop a product which goes inside esophagus and measure temperature with a precision of 0.1 degree to stop the heating before the damage for the patient. And this is disposable stuff. Just imagine fiber which can be bent like this, just to show you. It's extremely flexible material, and more of it. I can do something which you will never do even with a glass fiber. You see that?
Look at that.
Yeah, look.
I would like to see that while you are measuring the transmission, of course, but still, it doesn't break.
Sorry, and Slava, that's not toxic at all?
No, it's not toxic. There is some kind of, let's say, very weak cytotoxicity, which is even used by doctors sometimes for dentistry. But in general, it's non-toxic, non-hygroscopic, extremely flexible, and it's a material transparent from 3 microns up to 17 microns.
Let's talk a bit about the diameter of the core, because when you are addressing the medical market, many different companies have different needs for diameter. Do you have a specific constraints there? Do you manufacture fiber only with 1 core diameter, or can you actually have some flexibility for the end users on that?
No, we can, of course, produce this as the same material, but fiber diameter is much, much smaller. It's even difficult to see in camera. So this is like 300 microns. So, and we were the first who made for Darwin mission, for European Space Agency, we made a single mode fibers used, for the search of another, brothers and sisters in universe.
You said 300 microns core diameter. What is the largest core diameter you can actually make?
The largest, I don't know if it's enhanced, 1 millimeter usually it's enough.
1 millimeter.
But for example, when we did single mode, it was only 50 microns core. So core diameter was 50 microns.
So from 50 microns to 1 millimeter, any core diameter that you need, you can actually make, so that addresses.
To make life simple for customers, we decided to make 3 standards. It's 300, 500, 4 standards, 700 and 1 millimeter for standard diameters. But of course, we have a flexibility to make any diameter from this material. And in general, it's, as I said, 3 big areas of market: spectroscopy, laser power delivery, including quantum cascade lasers, this new trend. And of course, it's also more of it. We can collect by spider bundle, let's say power from 7 quantum cascade lasers It's our current project with Miracle, these 13 partners, to detect disease of cartilage. So that's why, and very thin fibers collect power from 7 lasers in one fiber, and this fiber goes into the knee to detect disease of cartilage. So that's why there are a lot of applications in medicine, and we are, we are really interested to put more and more efforts in medical application. We are not military guys. We knew that in general, this fiber will be very interesting for military application. But my preference, or our preference, is really to do more for healthcare, for food industry, for petrochemical, chemical, but not so much for military.
You know what I'm going to do now? Because I have a lot of questions for you and also in the room. But before that, there is something that you deserve. So I'm going to ask everyone in the room to unmute themselves, and give Slava and his fantastic team a very, very well-deserved applause, a real applause.
Thank you, guys. Thanks a lot. Thank you. Thank you, EPIC. Thank you, Jose, because we really would like also to use the chance to congratulate EPIC with a very new milestone, 700 members, last week, as I remember. So, and we are proud to be one of the very first and one of the, old member. It was less than 100 when we entered the club, and now it's 700, the biggest photonics club on the planet. Great.
You know what is the best way of congratulating me? To answer the EPIC question. What can you do for the other 699 members, and what can they do for you?
We are always in very special position. We are fiber optic bridge manufacturer. We are always between source manufacturer, laser, LED, spectrometer, and end user, detector, end user, and so on. So that's why all manufacturers of infrared sources, not only infrared, from UV to infrared, all manufacturers of detectors, spectrometers, endoscopes are our best friends. For us, it's very important to find partnership which will be ended up by complete product. Because I don't know, Jose, maybe you know better statistics, how many members of EPIC are really doing B2B business, components, and how many are system integrators. Because at the end, medical doctor, he's not interested in piece of fiber. He's interested in working system which help him to make, let's say, a signal, maybe acoustic signal, then he reached tumor. And we develop it right now with our partners in Rotterdam and other partners, because we would like to develop complete products. That's why our interest is system integrators and, of course, end users. Always, we should hear from end users what they want. Maybe we can realize their dreams, which were not possible before.
Yeah, and that's really the purpose. Every company in EPIC is a system integrator of their suppliers and a component supplier of their system integrators. That's the beauty of the European photonic industry. Slava, we have a lot of questions for you. The first one is coming all the way from Nanoplus, all the way from Würzburg in Germany. Lars Hildebrand, what do you have in mind?
Yes. Mm-hmm.
Yeah, I was. Thank you, Slava, for the very interesting tour. I'm very excited to join. I was interested in the Raman fiber. So when a customer or a doctor first comes to you asking for the solution for this Raman fiber, how long did it take for the development until the doctor really can see the tumors? Is that a year or two, or do we more talk like 10 years?
It's a good question, because what we have found, we started our investment in FOMOS project, fiber optic molecular sensor, in 2015. And then we simply, concept was very simple. You mentioned Raman. Raman is one of the methods. We used Raman, we used fluorescence, we used mid infrared and near infrared, because when we started from kidney, from renal cell carcinoma, then we found an answer that in general, every method helps to detect tumor margin. Question, how well, what is the sensitivity, specificity, accuracy? So that's why when we compare 4 methods, we can select which one is the best for particular tumor of particular organ. because organs are different. And for example, spectra of brain tumor, glioblastoma, is not the same. It's different from the tumor of, let's say, squamous cell carcinoma of tongue, oral cancer. That's why we developed one concept with Raman. Raman is also kind of double force, fingerprint Raman and high wave number. With Riverdi in Rotterdam, we used mostly only one simple marker, water and lipids. More water compared to the normal tissue, it means very high chance or probability of cancer. So that's why for each organ, for each cancer, I should say answer is special. And development, okay, I can say we have a project Russia with Riverdi within 3 years. Right now, let's say, working system is already used for half a hundred patients. But I think we are trying to do changes in, how to say, in protocol and procedures, because same system can be used for another organs. So that's why if it's a multi-profile clinics, then doctors from gynecology, from urology, for prostate, for breast cancer, they can use the same system for different purposes. So that's why let's communicate after this meeting. We can provide you much more details in this field, because it's a really big topic and we put a lot of efforts.
We have more questions in the room. The second one is coming from one of the most beautiful cities in the world, Bratislava, one of our suppliers of fiber optic and fiber components, Silex. Peter Lowy, what do you have in mind?
Hey, Jose, thanks for letting me in. And Vyacheslav, thank you very much for a very nice presentation of your company. It's really a pleasure to see our companies through this virtual tour, and I really enjoyed it. I'm also coming from a manufacturing background, and at Silex, we do for 25 years manufacturing and assembling of fiber optic products already. And as I have been seeing several production stages in your company, that reminds me a lot to similar technologies that we utilize here at Silex. And what I would like to propose to you, it's something that we can discuss definitely later on together, is that we are here to back you up with your growing tendencies. And we have great manufacturing capacities and capabilities in making fiber optic products. And if there is any stage of your production, and I have seen few that I can imagine already, then we are very happy to join forces with you and help you out growing without any further investments in your place.
Yeah, very good suggestion. Thanks for it. And I can say that we are not trying to do everything ourselves. Of course, we have a good partnership and we are interested in partnership with you, because our team is relatively small. We are less than 30 people. And right now our total space is about maybe 1,500 square meters. To be honest, last year was not easy for us because of very, how to say, negative case which happens with Boston Scientific, our biggest customer. Guys with 10 billion turnover decided to close one project with huge money invested for 10 years with FDA approval of the product. So, but nevertheless, we ended up with some small losses. But then, I really see that partnership in fiber optics, it's impossible to do everything ourselves. We must find your strong features, your advantages, put them together, and then, it's like a fist. So to put fingers together, and then we can provide to the end user the best product, where it will be your parts, our parts.
I make a living out of this, out of making people together. From the system integrator side, all the way in India, we have a company in the room that makes gas detectors and analyzers. The company is called Ambetronics. Ashish, what do you have in mind? What kind of cooperations can we do with you?
Yeah, as you know, in India, we have a lot of pharma companies.
Can you get closer the microphone to you, because we cannot hear you very well?
Yeah, as you know, in India, is okay now?
Yes, loud and clear.
Yeah, in India, we have a lot of pharma company, and now all the pharma companies going for digital 4.0, and now they need a lot of ATR probes. So online data acquisition while processing the pharma is very important.
Yeah, we are in pharma applications for many years. Our first delivery was to Pfizer in 2004. So that time it was, by the way, something which reminds me our Morphos multi-spectral fiber system, because guys in Sandwich, Pfizer in Sandwich Research Center, they tried to monitor reactions in reactor where they used mid-infrared with FTIR spectrometer, fluorescence, Raman, and near-infrared, all together, all big project. But that project was about, together with software, about 2 millions, more than 2 millions. Now the system we have in hands, it's not more than 100,000. So that's why, in general, we can really do something for liquids, for gases, your particular interest. Solutions are different, and they are based mostly on quantum cascade lasers, because quantum cascade laser has extremely narrow widths and can be tuned for different wavelengths, and then it's possible to detect not only ppm, we can detect maybe tens or hundreds ppb in gas phase. But question, where is your process and where is your optoelectronics? It's impossible to go with quantum cascade laser system inside reactor, but we can make a probe, a bridge between the pipe, between the reactor, and have quantum cascade laser spectral system at some distance from your process and control what is changed in gas phase in real time, even in different points. So to make kind of three-dimensional distribution of molecules in volume. And this reminds me a lot my grandma, when she did a very good borscht, you know, then soup, you know, then of course smell of this borscht goes around and everybody is excited. So I hope in your process, not always smell is perfect, but nevertheless products are very important.
We go from India now to northwest France. We go to Bretagne, and we ask David Mechen, who is the coordinator of all the Perfos activity, the manufacturing of specialty fiber in the Lannion area. David Mechen, thank you for being with us. What's on your mind?
Thank you, Jose. I would have just two quick questions. First one is, do Art Photonics work with photonic crystal fibers? In some ways, because as you might know, as you know, we are providing photonic crystal fibers, custom or not. So just question to know if there's some kind of collaboration available.
Very good question. And I really, how to say, I'm happy to be in contact with you, because in general, we do have already too many, let's say, technologies in small team. And of course, we could not cover everything. Photonic crystal fibers are extremely interesting. Concept is so good that even silica fiber can be used up to, let's say, 4 microns or even at longer wavelengths, because if it will be mostly air and it will be so-called negative curvature, or let's say so-called revolver fibers, when you have mostly air and only capillaries inside. So here we prefer to be your partner for assemblies in the moment, but we do not manufacture them ourselves. It's a tricky process how to make them with a high quality. So here we are not going to, how to say, repeat your achievements. We prefer to be your partner. In
that was what was on my mind. If like you have some I would say customers coming to you and needing like photonic crystal fiber, then definitely we can be in contact and work together.
Send us, you know, I think Jose and Suzette will organize, you know, later this kind of exchange.
Of course, email. I'll put you in touch. The next question is coming
and I
from...
have
yes.
Sorry,
sorry.
I have a second question, actually, a second quick. On the Art Photonics website, there's some products or some metal-coated fibers. I was just wondering if those, I guess they are not made in-house, the metal coating?
No, it's not in-house, but we have very good partners. There are, I should say, in general, maybe 3 guys in the world which are really able to make good metal-coated fibers. We are connected with all of them. 2 of them are my best friends for, I don't know, 30 years. So that's why it's not produced in-house here in Berlin, but it's done, for example, from the preforms we supply them. So they draw fiber with parameters which are interested for our customers. To be honest, we never try to make metal coating for photonic crystal preforms, but why not to try? So because metal coating, it's either aluminum or copper alloys, will give you better mechanical strengths. It's relatively thin. It's excellent heat dissipation. And when we did our biggest project with metal coated fibers, just imagine, it was 10,000 fibers, copper alloy coated, which combine energy from 10,000 diode lasers. So output power, total power from the bundle was 200 kilowatts. Customer was happy, and then he said, guys, I need 150 kilowatts more. So that's why metal coating is really something which can improve, how to say, exploitation parameters. Plus, it can be used at higher temperatures because no polymers will survive under 600 degrees Celsius.
There's a few more questions. The next one is coming from IR Sweep. Florian, what do you have in mind?
Yeah, my question before actually was already, Slava, what is the resolution? You talked about spectral resolution. What is the spectral resolution which would be important to measure those applications with a dual-com spectrometer? You said spectral resolution might be as important as well, not just speed.
I should say it's a good and not easy question because in general, your spectrometer already has a parameters which are unique for very high spectral resolution. Yeah. So question, if somebody needs even high resolution, then it should be guys who are really trying to catch small concentration of specific molecules. I can say that we used almost 25 years ago one project for atachlor detection in aquatic surrounding, and we used that time tunable diode lasers. If you remember history for this kind of lead salt diode lasers, which were cooled down to minus 200 degrees. So we detected 50 ppb. But to be honest, I don't remember which resolution was for that detection. But there are a lot of applications where so high resolution is not needed. That's why we should simply maybe find solutions what is in between.
Yeah, it's probably just for gas analysis, right? For gas analysis, it's only important to have such a high spectral resolution. For liquids or solids, probably 2 or 4 wave numbers is probably enough.
Right, but as you know, there are already a lot of gas sensors on the market which are dedicated for relatively high concentration, like carbon monoxide or carbon dioxide in the room. And the whole detector, which is like a matchbox size, costs $50. You know, so that's why to find a proper application area for this kind of extraordinary let's say, applications with very high sensitivity and relatively broad range for your spectrometer. It's not easy task. And I understand how to say, how difficult to be a pioneer.
And if I have just a quickly additional question, Jose, if you might ask, we discussed just at the beginning about this 10-meter ATR probe. Is that actually also for FTIR, or what was actually the application there, or the technology you were coupling this 10-meter ATR probe?
I can give you one funny example, really. My very, very first request for spectroscopy application of mid-infrared fibers came from Kronenburg beer in Strasbourg. Yeah. These guys, they have fermenters, you know, and these fermenters are relatively big. They asked, guys, can you put one spectrometer in our, how to say, cave, where we have our building, where we have these fermenters, and can we watch fermentation process in real time at the distance of 10 meters, 20 meters, what else? Yeah. So, and there are a lot of applications in industry where you have, how to say, no chance to come with your spectrometer close to the reactor.
Yeah, I see.
The next question comes from one of our personalities in specialty fiber in EPIC, Miguel Llera from Hoyte in Switzerland. What's on your mind?
Thank you, Slava. I'm really impressed about the flexibility you have shown before for your fiber, and especially when we talk about medical applications where we know that using glass optical fibers, they have a big issue, and this issue is the breakability of the fiber. So, apart using your fibers for spectroscopy or bringing light for some specific treatments, do you foresee, or have you already been able to make your fibers sensitive to detect temperature or strains or things like that?
I should say there are solutions which are on the market already, even industrial commercial solutions. When it's a silica fibers with Bragg gratings, or there are Multi-spectral brilliant scattering, Raman scattering, so which are used along the railways or on the bridges. And to my knowledge, we have partners for it. We made for them very special fiber, not with Bragg gratings, classic silica fiber, but metal coated, because they want to use it somewhere in wells. You know, there are some problems to measure temperature in petrochemical industry when you have a hole, which is, let's say, a couple of kilometers long, and you need, let's say, temperature monitoring along the dwell and even strains. I couldn't say that infrared fibers are the best for this solution because they have relatively high optical losses compared to silica fibers. That's why temperature measurement, what I mentioned, you know, is different. Infrared fibers, polycrystalline fibers are transparent in the range from 2 to 17 microns. And as you know, emissivity of black body at room temperature at 300 Kelvin has a maximum around 10 microns, 8 to 12. That's why all the infrared cameras which are used in military for temperature monitoring, for how to say cancer detection in breast, so on, they are all based on infrared arrays, bolometers, MCT arrays, and so on. But we are able to make a fiber optic bundle or even single fiber endoscope when the infrared image will be transferred through the flexible fiber. And then you can go around the corner, you can go into the belly and measure, let's say, something inside human body, infrared endoscopy. I mentioned one figure, Jose already was surprised, 40 billion endoscopy. And 40 billion with B. B, it's not millions, it's billions, you know. It's bigger than all laser market on the planet. But, you know, because they must illuminate and see inside, you know, what's going on. Great, it's used for many years. But if these doctors will have a chance to get only 1% of these endoscopes, which will help them to see in mid-infrared, then just imagine 1% from 40 billions, it's almost 500 million. So that's why question, we didn't found yet, how to say, partners who would like to put to add our fiber optic flexible delivery to their arrays. That's why we are trying to convince Teledyne, because Teledyne recently acquired FLIR, you know, and there are a lot of other companies who are simply manufacturing. We do some products already supplied to customers. Company Optris here in Berlin, they produce infrared cameras, and of course. Here, it's great chances. It will be not only endoscope, just imagine it can be spider. You can surround engine by fiber optics and measure three-dimensional picture in infrared with one array. So that's why it will be a chance to make three-dimensional infrared imaging in the future if our flexible fibers will will be used for that purpose.
On the 10th of May, EPIC organizes the EPIC meeting on urology. So write that date in your calendar. But we have a question from one of our mid infrared detector manufacturers, 2 to 5 micrometer detectors from Denmark. Beautiful flag behind you, Peter Totrop. What's on your mind?
First of all, thank you, Slava, for the tour. We have a customer that's asking for, does there exist a reflection probe from 2 to 5 micrometers that matches our spectrometer probe?
I remember you have really great machine because it's really fast, and it's not using any moving parts. So fibers, for that range, I can tell you that we have not only PIR fibers, because PIR fibers have relatively high scattering in short wavelengths. But when it's needed for, let's say, 1 to 5 microns or 6 microns, then the best fiber is like this. This is chalcogenide fiber. I don't know if you can see it,
I can see it, but can you make a reflection probe out of that?
Yes, sure.
Because today you only have a near infrared, you don't have a mid infrared.
No. We are manufacturing a lot of ATIR probes using polycrystalline fibers and these fibers. But when we use chalcogenide fiber, we use simply another optics. If for PIR fibers, it's used with diamonds, silicon or zinc selenide or germanium. For chalcogenide, for the range 2 to 6 microns, 2 to 5 microns, it's a cubic zirconia. So it can be window for reflection probe, or it can be conical tip for ATIR absorption measurements. So yes, no problem. It can be range of your spectrometers, can be reflection probe.
I'll tell them. Thank you.
You know what I like in EPIC? We have lots of complementarity technologies, and also Peter Totrop, you're looking for 2 to 5 micrometer. Chalcogenide is a very interesting material, fluoride fibers as well. And I have in the room Samuel Paulin from LVF, from Lever Fluoré, the company with the most beautiful name in the whole EPIC network. Samuel, Peter is looking for a supplier of 2 to 5 micrometer fiber solutions for a particular probe. Can you help there?
Yeah, of course, because this wavelength range, we are very used to it, because from 2 to 5 microns, fluoride glass fibers are suitable. After that, let's move forward. We know that it's not that easy, because devil is in the details, but this is what is of interest. But of course, there is a great room for collaboration. We have already discussed with Slava. Yes.
Yeah, we already agreed, Jose, that with guys with Lever Fluoré, first of all, it's my old friends. My very first visit to West Europe was to University of Rennes, in in Bretagne. So it was in '84. Since that time, I hope that Jacques Lucas is still active, and Michel and others, good friends. So that's why, of course, we would like to have fluoride glass fibers, which will come, let's say, from Lever Fluoré, when we can really complement it with PIR fibers, hollow waveguides, what else?
Yeah. We have identified real synergies. And actually, we think it's worth thinking about for different kind of solutions, using different technologies of fibers inside the same device. Because for specific developments, yes, different fiber technology are compulsory. And for that, we need to collaborate to create standards, to offer the same interface in order to offer a product that can be easily integrated.
I am very happy that we to have the specialty fiber solutions in the mid infrared. Yes, please, Slava, go ahead.
Yeah, fluoride glass fibers, it's simply the best for the range of 2-4 microns, because they have the minimum optical losses. And we have excellent partnership with my friend in California, doing kind of drawing of fluoride glass fiber in International Space Station. If you remember, Jose, it was interesting workshop when it was a company made in space, presenting some results, but it's not only one manufacturer in the International Space Station. We work with a company, D-Star Communication, and they really did already a couple of times drawing of fluoride glass fibers there. And a friend of mine, Dmitry, he's highly interested in collaboration with Lever-Fleury. So that's why here I see additional, how to say, topic to work together for the
We had a fantastic Q&A, one of the longest. Lots of questions were asked. I always want to never interrupt a discussion. Is there anybody else who have a question, a comment, or some room for cooperation? Slava is a star on starting cooperations with EPIC members. On that, he's really the #1 cooperation user of the EPIC platform. Any ideas? If I'm going to make a countdown, I love countdowns. You know, I do 5, 4.
Actually, I've got an idea because we've been working for very long about supercontinuum laser sources. And now we've got several ranges of supercontinuum sources. And as you showed, Slava, very interesting devices and setups for spectroscopy, I think it should be interesting to test mid-infrared laser sources.
Sure, because it will be excellent coupling efficiency. It will be much better than this FTIR. Sure.
Yeah. It's of great interest. Yeah,
sure. And what I would like also to mention, to comment, Jose, you know, one important news which we try to, let's say, to push through the community because we are doing fiber optic products to mid-infrared, how to say, pioneer of mid-infrared fibers. And I would like to remind everybody that plan of EPIC is to create infrared photonics alliance. And maybe, Jose, you can say some words how you plan to do it.
So the secret of the sauce is that we need to work together. And the secret of the sauce is that to go to many of our customers, we need to increase volumes for reducing one of the most expensive parts of the system, which is still the laser. So we need to increase the demand on that. So I think all of us, the companies making the camera detection, like Englir, the companies making the fiber solutions, like LBF or Art Photonics or Coractive, the companies making the whole packaging, the whole integration into different tools, like today we had IR Sweep. All of us need to collaborate. EPIC is the platform for that. We will kick off the mid-infrared alliance in I think it's in a couple of months, and then we're going to go to every single end user conference all together with a dedicated booth, with dedicated demonstrators telling people that this is the future. We can enable now testing from 2 all the way to 15, 16 micrometers. We have huge success stories on the supercontinuum generation, on the quantum cascade lasers. And you know what is best, Slava? The best technology in the mid-infrared is manufactured in Europe. And that makes me extremely, extremely excited.
Right. And I would like to make one suggestion, just because of the fresh news from Brussels. As soon as the program, to finance development of high-tech technologies in Europe will be funded for almost 100 billions, within 6 years. EPIC already was a member of interesting platforms. You remember MIRFA platform.
Yes.
But I think with Infrared Photonics Alliance, we should really look for the calls, distinct calls from Brussels, where we can really be focused, I should say, better than MIRFA, to the end users. We really need end users, because then we can develop
all together what they need.
Platform where it will be.
But I do want. What I want is not the taxpayers to pay. This is my dream. I don't want the taxpayers to pay the bill. I want Volvo. I want Daimler. I want Bosch. I want Siemens. I want Boston Scientific. I want these people to pay the bill. I think we have to, on one hand, combine the pilot production, and on that it's important to get the funds. But the Mid-Infrared Alliance, as you said very well, Slava, needs to go to the end users and show them this technology comes with a price. you need to pay for it. And when you order 1 million, the price will be reduced by 90%. So let's all work together. You can get 1 million as soon as possible. And that's going to be super exciting. Samuel is going to be part of the group on this, and Peter and David. And it's going to be a really epic few years on the Mid InfraRed Alliance. I can't be more excited about this.
Okay, I agree with you. We need these big boys because unfortunately the statistics of photonics shows, it was Timatis data, as I remember, that, or not Timatis, SPIE, you know, that 80% of small and medium enterprises in photonics really deliver to the market something like less than 10% of the products. And only, let's say, 20% of the manufacturers, big manufacturers, they deliver 70%. And this huge contrast, to me, is not, how to say, best, let's say, ratio, because companies, they are really slow, I should say. And it's difficult to convince decision makers that they should really watch, let's say, new technologies and support them from very beginning. They prefer to buy it when it's everything ready. When you are already 20 years old, you know, our company is 22. We have already interesting offer, you know, to acquire our company. But I didn't decided that it's time to do it because the customer was not ready to develop these technologies. And that was kind of my barrier, because I really would like to have partnership with big companies, but really to find who will be able to listen and see the future, not future for tomorrow, future after tomorrow, something like that. So we must work on this topic. It's not easy, but I think together with EPIC, you know, and partners in EPIC, we all understand where is the problem, and we should find proper means, you know, to win.
You know what is the worst part of this? That we can't all go together for dinner right now, because it would be a really, really, really fantastic dinner. I can just imagine all of us holding a beer in a bar and really having a really fantastic discussion. This was epic. Thank you so much, Slava. Thank you, all of you, for attending this meeting. It was great. Until the next time, you know, wear a mask, wash your hands, get vaccinated, because I can't wait to start traveling again. See you soon. Bye-bye.
Yeah, see you. Bye. Thanks.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye.
Thank you.
Bye.